Welcome back to my channel. So today I am discussing about the conservation of angular momentum. So in previous video I discussed about conservation of linear momentum, that is p is equals to mv is equals to constant. So their conservation of it is a conservation of linear momentum. In this video I am going to discussing about angular momentum conservation. So initially we have to consider that angular momentum of a particle p of a mass m about a point 0. Okay, what we are considering? We are considering the angular momentum of a particle, okay, at the point O which contain a mass m, which contain a mass m. Okay, the distance is r, so angle is theta. So we know that angular momentum, it is represented as j. So j is equals to r cross p. R is the distance and p is the linear momentum. So we know that p is equals to m, mass into velocity by the linear momentum. So on this particle at point O, torque is acting. Torque is acting, okay, at a point O. So it can be written as tau is equals to r cross f. R is the perpendicular distance, f is the force acting on the particle. So tau is equals to r cross f. Okay, so name it as the equation number 2. Differentiate equation 1 with respect to t. So we have to differentiate this equation with respect to t. So dj by dt is equal to d by dt of r cross p. So it is in the form of u into v. So we have to first differentiate u keeping constant as a p, and that is v, okay, and differentiate p keeping constant as r. So that only I did here. So dr by dt into p plus r kept constant and differentiation of p. Moving further, dj by dt is equal to r cross f. Why I took this? Because we know that dr by dt, rate of change of displacement, is nothing but velocity. Okay, so in the place of dr by dt I can write it as a v. So I know that linear momentum is mass into velocity, just I written here. So from the vector law, this is going to be 0, so this term going to be 0. Okay, so remaining only this term. We know that Newton's second law, dp by dt is nothing but your f. Okay, so r cross f is nothing but your tau. So just write this, tau is equals to dj by dt is equal to d by dt of j is nothing but r cross p. Okay, torque acting on a particle is 0. That's why. So the torque acting on a particle is, let's take it as a torque acting on a particle is 0. Then this entire become equivalent to 0. Then j is equal to constant, nothing but our conservation of angular momentum is holds good. Thanks for watching. Keep subscribing and like my video.